we're basically going to want to actually set up a tortoise and a hare. So we'll have something as a tortoise equals 1 step and a hare equals 2 step. All right, so say we have the tortoise and hare here. So for this, if they both land on the same node, you have a cycle. If the hare lands on null or the tail, you do not have a cycle. So in this example 1, I'll go ahead and go over how we can check this. So say we have a tortoise and hare. We have the hare move forward 2, tortoise move forward 1, hare move forward 2. All right, we already know that it's a cycle. The tortoise moves 1, hare moves 2, tortoise moves 1, hare moves 2. Well, as you can see here, we have the -4 as our detected node. So after this, once we figure this out, we're going to want to put a pointer on the head and a pointer on the meeting place. Once we do this, we're going to want to traverse by 1. So if we traverse 3, we get to 2. If we traverse from -4, we also get to 2. And that is how you know where the node is. All right, let's go ahead and get into this. As I've explained how this works, we're going to go ahead and code this out. So here we have the var detect cycle and the function as the head. So for this, we're going to want to continuously run till break. So let's go ahead and start by adding if bang head return null. All right, so this is basically run till the break. Here we're going to want to let the tortoise equal head and the hare also equal head. This is just an easier way to explain it. As I told you about the tortoise and hare, we might as well use the tortoise and hare. Now we're going to want to create a while loop so that they will both move forward by 1. So while is true, we're going to want the tortoise equal tortoise dot next and the hare equal to the hare dot next, moving forward by 1. All right, now that we have this, we're going to want to create an if statement. So we can have here if the hare is equal to null, and then we'll have an or, so or hare dot next is equal to null. And then we're going to want to return null. That means that there is no linked list cycle. All right. Now that we have this, we are going to want to hop into an else so that we can move the hare an extra step after. Since we're doing the hare is 2, the tortoise is 1. So we'll do else hare is equal to hare dot next. Perfect. All right. Down here we'll have the if statement where they're both pointing at the same node. So here we'll go ahead and do the tortoise is equal to hare. Then we're going to want to break out of this since we have found where we want to go. All right, after this, like I said in the beginning, we're going to want to set up our 2 pointers. So we can go ahead and let the pointer 1 equal the head. And we can either use the tortoise or the hare in this. I'll go ahead and just use the tortoise. If the pointer 2 is equal to the tortoise, there we go. All right, now that we have both of those as a move to me, we can go ahead and set up the last part. So here we're going to actually want to set up a while loop. So we're going to do while the P1, which is our pointer 1, is not equal to P2, then we're going to just want to move them both forward. So we'll do P1.next, and then we'll do the P2 equal to P2.next. All right, great. After this, we're just going to want to return. We can return the P1 or P2. I'm just going to return the P2. All right, let's go ahead and do a check through this, make sure that we have everything correct. All right, it looks like everything is correct. I'll go ahead and run the code. All right, looks like it was accepted with the test case. Let's go ahead and submit. All right, great. So yeah, guys, that was basically our solution to this problem, which is the linked list cycle. And we used a solution that consisted of an algorithm, which was the Floyd's tortoise and the hare, which gave us a very nice memory usage. And we also kept that same time of ON. All right, guys, hope you enjoyed this. Go ahead and test it out for yourself, and I'll see you in the next video.